Hi, welcome back to the OWASP Appsec tutorial series. My name is Jerry Hoff, and this is episode number 3, Cross-Site Scripting. This series is for anybody who wants to learn more about building secure web applications. And in this episode, we're going to focus on one of the most serious and prevalent vulnerabilities out there, cross-site scripting, usually abbreviated XSS. Now, cross-site scripting is a very serious problem, affecting a large majority of applications on the web. And unfortunately, many developers aren't even aware of the problem. On top of that, XSS is messy. There are multiple variations, and there are no easy solutions to fix the problem. In this episode, we're going to focus exclusively on the most serious variant called stored cross-site scripting. But don't worry, we'll come back and discuss other variations in future episodes. So, in the next 10 minutes, I will show you 3 separate examples of cross-site scripting. One will be super high level, the other 2 will be more detailed. And towards the end of the program, I'll point you to some resources where you can find out more about preventing this attack. So, let's get started. Cross-site scripting is one of the most well-known vulnerabilities listed in the OWASP Top 10. And by the way, if you haven't read through the entire Top 10 list, I highly recommend you do so. A PDF of the list can be downloaded from OWASP.org. XSS has been in every edition of the OWASP Top 10, and in the 2010 edition, cross-site scripting holds the number 2 spot, just under SQL injection. XSS is extremely prevalent in web applications and very easy for attackers to find. Plus, exploiting an XSS vulnerability is usually pretty straightforward. The attacker just needs to know a little JavaScript. XSS is not tied to a particular platform or language. All popular web programming technologies are susceptible to cross-site scripting. At this point, let's dive right into example number 1, which will demonstrate at a very high level an XSS attack. But first, to give it some context, I want to recap the attack we learned in the last episode at the same high-level perspective. Let's assume an attacker targets a totally random website, like maybe a popular gaming forum. As was illustrated in the previous episode, the attacker crafts a malicious request containing SQL and then sends it across the internet to the target website. The illegitimate SQL runs against the database server, and unauthorized data is returned back to the attacker, such as email addresses and passwords. So the target of SQL injection is clearly the database server. However, in cross-site scripting, things are not always so straightforward, because the target of a cross-site scripting attack is usually another user's web browser. Basically, XSS is another form of injection. This time, it is script injection, and the vast majority of these attacks are written in JavaScript. So cross-site scripting is when attackers use vulnerabilities in your web application to distribute malicious scripts to other users, which then run in those other users' web browsers. To illustrate this at a high level, imagine an attacker posts a comment to a popular gaming forum, and inside of his comment is some malicious JavaScript. The attack is sent to the game forum, where it is stored like all other comments. But from that point on, any user who views the post in the forum will receive the attack, making for very unhappy users. So now that we understand what the attacker is trying to accomplish, let's look at another example in a bit more detail. Imagine an employment website. Here, the intended workflow of the application is that an employer visits and posts a new job opening. And to keep things simple, imagine there's only a single field, the job description field. The employer enters the description and clicks submit. The employer's browser then sends the request across the internet to the employment site's web server, where it will be stored in the database. From that point on, every time a visitor views that job opening, a dynamic web page will be created. And as you can probably imagine, the generated web page will consist of some static content, which includes the header, footer, images, and so forth, and the dynamic content, which is the job posting. The static and dynamic contents are merged together, and the HTML response is then sent down to everybody who views that particular post. Of course, the end users don't normally see the HTML, nor are they aware of the static and dynamic nature. They simply see the browser's representation of that HTML. So the web application does seem to work. However, it is definitely not secure. So to illustrate what can go wrong, imagine the same scenario as before, only this time, a malicious prankster decides to have a little fun with the employment website. Like before, a job description is entered, only this time, some JavaScript is appended to the end of the description. Note, for the sake of legibility, I am displaying just a single JavaScript comment. Obviously, a real attack would have some actual JavaScript, or would at least reference an external JavaScript file. The attacker hits submit, and the request is sent across the internet, where it is stored in the employment sites database. Just like before, the web application merges the legitimate static content with the user-supplied dynamic content. Only this time, the dynamic content contains some malicious JavaScript, which is the XSS attack. The two pieces are merged, and like before, the resulting response is sent to all visitors. The visitors will still see the employment posting. In fact, there usually won't be any visual indication of the attack at all. The malicious JavaScript will quietly run in the user's web browser. At this point, you might be wondering what attackers can actually do with JavaScript. Well, one common attack is to steal another user's session ID, which can be accessed through the JavaScript document.cookie value. If an attacker can steal a user's session ID, the attacker can then jump into that victim's session without a username or a password. JavaScript can also be used to rewrite any part of the web page. In some cases, they may simply deface the website, but a more serious attack can easily be imagined. For example, if an attacker finds an XSS vulnerability in a banking website, they can easily overlay a login screen on top of any legitimate page. A normal user would not think twice about entering their credentials, since the URL would be back to their own bank website. Only this time, the username and password would be sent directly to the attacker. Now, at this point, people often ask if we can simply block the script tag and remove the XSS threat. The answer, unfortunately, is no. Example number 3 illustrates an XSS attack without the script tag. Imagine a guestbook application that prompts a user for their name and then generates a web page putting the user's name in a text box. A legitimate user will type in their name, send it to the web server, which is then inserted into the text box's value attribute. Now imagine a malicious user who enters their name, followed by some HTML and JavaScript. Like before, the user's data is sent to the web server. Only this time, the message alters the text box itself. The quotes line up perfectly, and a new JavaScript event handler has now been inserted. So when any victim hovers their mouse over that particular text box, the event handler will activate and the malicious JavaScript will run. Hopefully at this point, we can agree XSS is a serious problem. So let's talk about fixes. XSS vulnerabilities are the result of developers not properly validating and encoding user-supplied data. So in order to stop cross-site scripting, we have to educate web developers how to effectively validate and encode user-supplied data. For proper validation, make sure you're using a positive whitelisting approach. And for encoding, realize that encoding must be contextual. That is to say, you will have to encode the data differently depending on where it's placed in a web page. The idea of contextual encoding can be quite confusing. In fact, I will go over this concept in great detail in a future episode. But to find help now, let's turn to the OWASP website. Once you are there, search for the OWASP XSS Prevention Cheat Sheet. This cheat sheet will give you more information regarding the different contexts you need to be familiar with. The contexts are clearly listed out and defined. I highly recommend reading through this entire cheat sheet. As for the encoders, I encourage you to download the OWASP eSAPI project, which contains multiple contextual encoders necessary for properly preventing cross-site scripting. One final note. In this episode, we only covered a fraction of the overall threat that is cross-site scripting. We only covered one variation, stored cross-site scripting. There are a few others, such as reflected, DOM-based, and even a way to run cross-site scripting against Flash and Flex applications. We will try to cover all of these variations in future episodes. So that's it for this episode of the OWASP Appsec tutorial series. If you want to find out more about future episodes, make suggestions, or contribute, please contact me by Twitter or email. Special thanks to all those who helped make the show possible. This is Jerry Hoff signing out. Thank you, and I'll see you next time.